Hello guys, welcome back to Mason African Motives, still working on engineering. So in this platform, we are going to just focus on mathematics N1, which is the paper that was actually written in 14th of November 2022. So I just want to see at least what we were supposed to do in this question paper. So without wasting much of the time, we just want to quickly see the instructions and the information that we are given. Remember your instructions, guys, and the information. Read everything and understand everything that you are given from the question paper. All right, so we had the first question, which was to simplify each of the following without a calculator. So take note here, we are not allowed to use a calculator. By using exponential laws, show all steps. So here we are using the laws of exponents. All right, so we had the first part. I'm just going to push this aside so that we can have our question nicely here. So it's gonna be 1.1. All right, so let me just write this here. So we had 128x to the exponent of minus 3. Take note. So as we know our laws, guys, when we are multiplying, we are going to add the exponent. So here we just have to multiply the numbers, which is 128 by 16, so that you can even multiply, but this one does not need even for you to just multiply here 128 by 16. Which is something like 2048. So we are going to have 2048. Then on this part, take note, these two, we are multiplying. So we are going to add the exponents, which is minus 3 and minus 6. So it's going to be x to the exponent of minus 3 plus minus 6, which is the other power or the other exponent here. We're going to add this. Still, we are dividing. So don't forget here that we are dividing by x to the exponent of -9. All right, so let's simplify this first so that we see what you're going to have. Remember, plus or minus, we're going to obtain a negative here. So it's minus 3 minus 6, which is minus 9. Or you can even confirm on your calculator, minus 3 minus 3 minus 6, that one you can just confirm your answer, which is -9. So that means we are going to have 2048 x to the exponent of -9 divided by x to the exponent of -9, like that. So we are now back to division, where we know that when we are dividing, now we are going to subtract the exponents. So meaning to say this, we can even write it as 2048. So this is what you're going to have, x to the exponent of -9. Remember that we are dividing. So what are you going to do on the exponent? We are going to subtract. So what are we subtracting? The exponent, which is already there, which is -9. So it is going to be a -9, like that. So knowing that minus and minus, that's a plus. So this is going to give us plus. So it's -9 plus 9, which is a 0. So you can even confirm -9 plus 9, that's a 0. So that means this is going to give us 2048 x to the exponent of 0 here, knowing that any number, as long it is raised to the exponent of 0, it gives us 1. So that means this is going to be 2048 times 1, which is just 2048. So we no longer have the x there. We are just left with a normal number, which is 2048. So that is what we had clearly there. I think it's clear. The other part was to simplify without also using a calculator the following by using logarithmic laws. Take note, the laws of logarithms are the ones that you're supposed to apply. So I want us to see something here. If we are to check properly, these two we are just adding. This is just like 3y plus y. It's just a normal addition. So here you can add. You don't panic here. It's just supposed to add 3 plus 1, which is 4. So this was going to give us 4 log of x over here we've got log x squared, which we can apply our laws of logarithms. Remember from your laws of logarithms, I'm just going to have it here. We know that if we've got an exponent, let's say we've got log a to the exponent of b, we just need to drop this exponent, it will be b log a. So that was the case here. We've got to drop the exponent, which is 2, so it's going to be 2 log x. And that means we can cancel the log x are the same. So this can cancel 2 into 2, that's 1, 3 into 4, that's 2. So which means we are going to remain with 2 over 1, which was going to give us 2. No logarithms is, no log is going to be on your answers, just final, which is 2. All right, 1.3, write down, write the following in exponential form, guys. This is a direct method that you are given. Logarithm of a in base of b, which is equal to c. In exponent form, we know that a is equal to b to the exponent of c. So that's what we have here. We already have our a. Okay, let's just have this way. We have our a here, our b, and our c. So that means in exponential form, I'm just going to write my a here, which is the square root of 3. So it is going to be square root of 3 is equal to b, which is x, which is the base. So it's x to the exponent of c, and our c is a half. So it's x to the exponent of a half, like that. That is exponential form, just like that. All right. So guys, make sure that you understand the questions. That is the most important part. Okay, number 1.4, write, we are given A7A to this, whatever that you have, write the expression in descending powers of x. So they are saying we have to write in descend, like descend from the highest power up to the least power. So we can't do this without, before expanding. So the first thing that we had to do was to expand the brackets so that at least we can see the exact part. So let's expand here 7x times a, which is going to give us 7ax. We have got 7x here, which is being multiplied by a b, of which you can just leave it like that. I think that was the most important part. We can expand or you can leave it like that. Okay, so if we had to expand, this was going to give us 7bx, which is one and the same thing, minus 5x to the exponent of 4, minus 3x squared over 4, minus 4, minus 2x to the exponent of 5. So descending powers, meaning we have to start with the highest to the lowest. So we're going to move from the highest to the lowest, that is descending. So the highest exponent is this one of exponent of 5. So we're going to have our answer is minus 2 x to the exponent of 5, followed by this one of 4 exponent of 4. So it's minus 5x to the exponent of 4, followed by this one of 2, which is minus 3x squared over 4, followed by these 2. So these 2 can just be together. So if you were to expand the brackets like this, you are going to write this as it is, or you can just leave it in this manner that it was. So which means you can write it as plus 7x into a minus b, like that. It can be fine. Then we have got a constant, which is -4. So we've got a constant here, which is -4. So that was the answer in descending powers. So like I was saying, here we can choose to write it on this part here. We can choose to write this part. It's still one and the same thing. All right. So that was our 1.41, 1.42. What is the constant term of the expression? A constant is, that's a term that is just a normal number. There is no x there. We are just having a normal number, and the constant, which is the number that we see, is -4. So the constant term was -4. 1.43, what is the coefficient of x squared? The coefficient is the term, the number that is affecting x squared. So we've got our x squared here. If we are to cross-check, the number that is affecting x squared is this -3 over 4. That is the coefficient of x squared. So meaning our answer was going to be -3 over 4. That was it, guys. Just like that, we are done. All right, so we've got our 1.43, 1.5. Show all calculations and use logarithms to base e. That is the natural logarithm, to calculate the value of x. Okay, they want us to calculate the value of x. So what are we going to have in this case? For us to have the normal x that we know in this case, we are told the base that is for us to use in this case, to say for whatever that we are going to use, we are going to calculate the value of x, but we are supposed to use logarithms to base of e. And what is this logarithm which is in base of e? That is the ln. Ln, like this, ln x is the same as log x in base e. So we are supposed to apply that. So let us try to apply this information. So this allows you either to use any of these two. So what I'm going to do here, we're just going to introduce our log, just like what we are being told to do here. So the moment you introduce log, it also affects this side here. So you're going to have something like this, logarithm of x, which is in base of e, the one that we are being told to use of base e, which is ln. And equating here, the moment you introduce log, that means this will be like this logarithm. We've got base e, but we've got this path, everything here. So it's going to be e over the square root of 0.45, but everything like this is in base of e. All right, so let's see how we are going to win, or how are we going to simplify this? Knowing that our laws of logarithms still has to be applied. Which laws of logarithms are we talking about? Remember, if you are dividing this here, the logarithm of a over b simply means that we are subtracting log a minus log b. That is the condition here we are dividing. So in this case is the same, even though we've got a base of e here, we are going to do the same thing. That means we are going to have the logarithm of x in base e, which is equal to the logarithm of, we are going to subtract, which is logarithm of e here in base of e, minus the logarithm of this square root, which is the square root of 0.45 in base of e. All right, checking here, we are now back to the laws of logarithm, knowing that this part here is going to give us 1. Guys, we know this logarithm of a in base of a is equal to 1. So that's a 1 here. So meaning we are going to have an equation now like this. The logarithm of x in base e is equal to 1 minus the logarithm of the square root of 0.45 in base of e. All right. From this part, what we need is to find x. So we are going to apply now the laws of logarithms. That is, we can write this in exponential form to have our x here. So what are we going to do? This x that we are going to have is going to be the base, which is e to the exponent of the answer that we have. So it's going to be e to the exponent of 1 minus the logarithm of 0.45 under the square root, like that. So in base of e, remember your base, don't forget the base. Okay, so the moment we do this, we've got our x. So you can leave our x like this, or we can actually use our calculator at last to simplify the value of x that we have, which is going to be 1. We said e, so let me just increase this one. All right, so we are going to have e, that is a shift. We've got e here to the exponent of 1 minus the logarithm. So we've got this part here, remembering that we are in base of e. So this is base of e. All right, everything here, we've got the square root of 0.45. So that's 0.45 under the square root like that. All right, and we need to close the outer bracket like this, and this can give us a resultant of 4,052. Okay, so that's 4,052. 4,052. So that is the value of x. So you can confirm here, if we are getting the same answer, we could have just confirm. We can just confirm from this one that we already have here. We said x is e over this, so we're going to put a fraction. So we've got e to the exponent of 1 over the square root of 0.45. 0.45. Let's see if you're getting the same answer. Yes, that's the same answer. So as you can see, that's it. So there are so many ways. I don't know which one exactly do they want us to use, but this is an application of log. So we've got so many ways that we can use to simplify these typical questions. So I just hope the one that we have is actually fine. Okay, so let's move on to question 2. Divide the following. All right, so there we just have to apply our long division. Okay, so let's just work it this side. I think it can be enough. So remember that we are dividing by 2x minus 4y is the one that is going to divide this expression 2x minus 4y. Okay, so as we know that the one that is going to divide is one that we write here. So this is 2.1. So we are dividing by 2x minus 4y into the whole expression, which is this part here, which is 4x cubed. We just have to write this as it is. That's 4x to the exponent of 3. Minus 2x squared y minus 14xy squared plus 4y cubed. Okay, that's it. So we've got this expression being divided by 2x minus y. So let's perform the long division, guys. As we know that we are supposed to divide, multiply, back, subtract, so forth and so forth. Then you repeat all those stages. Okay, so 4x cubed divided by 2x always is the first term versus the first term. So 4 divided by 2, that's 2. So we're going to have 2 x cubed, 2x squared. So it's going to be 2x squared. Remember that you have to multiply, but when you are multiplying, you multiply this everything. So it's 2 by 2 by 2x, which is going to be 4x cubed. Okay, then we multiply 2x squared by here. So we have to multiply, sorry for that. So we are supposed to multiply here, which is going to be minus 8x squared y. Then we can subtract. So if we subtract, that's a 0 here. 4 minus 4, minus 2, minus, minus. We know that a minus and a minus, that's a plus. So it's going to be minus 2 plus 8, which is 6. That's a positive 6. X squared y, then the rest, we have to drop them down. So we've got minus 14x y squared plus 4y cubed. Okay, let's divide again. Always first term versus first term. So it's first term versus first term. 6 here, divide by 2. So that's a 3. So we're going to have 3x. Remember, we've got x squared and x. So it's going to be 3x, but y is going to remain. We multiply back, is going to give us 6x squared y. We multiply back here, which is going to be minus 3 by 4, which is 12x y squared, because y and y here is going to give us a squared. Then we have to subtract again. So take note about the procedure, guys. The moment you subtract, it's 6 minus 6, that's a 0 here. Minus 14 minus 12, that's minus 14 plus 12, which is minus 2. So we're going to obtain minus 2xy squared. We have to drop this exponent, this part here, which is like this. We divide again 2x versus minus 2x here, they cancel. So you're going to remain with minus y squared. Okay, so that's minus y squared. So if we multiply back, minus y squared times this is going to give us minus 2xy squared. Minus y squared times minus 4. Take note, it's a minus 4. So it's going to be a positive 4y cubed. As you can see, these two are the same. So the moment that you subtract, definitely you're going to obtain a 0, 0, because these two are the same. So here we are going to obtain 0, 0. So that means after dividing, we are going to obtain this expression. So that was the long division that we're supposed to apply. Divide this expression by this expression. The one that you're dividing is the one that you are going to write on this part, like what we see. Okay, so that was our 2.1. Then 2.2, what must be added to this expression that we see? What must be added to this expression to give this expression that we see on the other part? Okay, it's like this, guys. Let us just take a normal consideration. We have got 2. What must be added to 2 so that we get 5? That's the question. What can be added to 2 so that we can obtain 5? What do you simply do? You simply, what you must get 5 minus 2, which is 3. Then you know that if you add 3 to 2, you're going to obtain 5. 3 plus 2, that's 5. So what must be added to this expression so that we get this expression? So we simply have to subtract this expression minus this. That is what the question was simply asking you to do, just like that, guys. So that is what we're supposed to do. So let us subtract and see so that we know what was supposed to be added. So we're going to subtract 5 minus 5x squared minus 3x minus that part that we are supposed to add to, which is this expression of x plus 2x squared minus 3. So let us subtract. That's 5 minus 5x squared minus 3x, negative times x, that's negative x, negative times a positive, that's negative 2x squared, negative, and the negative there is going to be a positive 3. So that means we can collect like terms 5 and 3. 5 plus 3, that is 8. All right, we move on to x, the constant, the part with x minus 3 minus, this is same as minus 1x. So it's minus 3 minus 1, which is minus 4x. Then we move on to this one of x squared. We've got minus 5x squared and minus 2x squared. So if we are to subtract here, minus 5 minus 2, that is minus 7. So it's going to be minus 7x squared. So this is what is supposed to be added to this expression so that we get this just like that, guys. We've got your marks. All right, question 3, factorize fully factorize the following expression. All right, so let's just write this down, our expression. That was 2x minus 2y. So the first thing was to expand this bracket, as you can see, guys. We have to expand, or we can just leave it like that. Okay, plus 3a into y minus x. Okay, if you don't want to expand, then leave it like that. But I want you to see something. Here we are supposed to obtain a bracket which is the same as this one of y minus x, but here we have got 2x minus 2y. So what are we supposed to factor out? We are supposed to factor out minus 2 so that we can obtain a positive on y and negative on x, because x is negative. So our x here is going to remain as negative. Negative and negative, that's a positive. Y is going to be positive. So as you can see, this bracket and the other bracket are the same, y minus x. These two brackets, they are actually the same. Take note, guys, if I am to write like this, 2 minus 1, minus 1 plus 2, these are the same. So that was the condition. And we know that once these two are the same, I just have to write one of the brackets out, which is y minus x, or you can write it like this, I don't know. Then you are left with minus 2 plus 3a in another bracket, which is 3a minus 2, of which you can write it as minus 2 plus 3a, or just like that. So that was what we are going to have in this case. So as you can see, guys, it was actually clear. I've got 4 marks for that. So this is how they can ask these questions, guys, as you can see. All right, the 3.2, simplify the following. That's an expression that is good 4 marks. So what can we do? Expand brackets first, that at least we can get something. Okay, so let's expand. We are going to have 12x cubed y there, then minus 3 and 3, that's a minus 9. So we're going to have minus 9xy. Okay, then now let's expand negative 3 by negative 5, which is positive 15 y squared x. Okay, that's what we have for now. And everything here is over 3xy. Okay, so what is going to happen here? Let's see, guys. Do we have something that is composed? Here we can't add the top part here. We can't add the numerator because these are not like terms. So, but at least we can factor out the highest common factor between these 12. We've got 12 here, we've got 9, we've got 15, which is 3. So you can factor out 3. We've got x here, which is xy. So you can factor out 3xy. That means 12 divided by 3, which is 4. So you're going to have 4x. Okay. Minus 9xy divided by 3. It's going to be minus 3. We move on, 15 divided by 3, which is going to be 5y squared. And y here, we're going to have y like that. Everything over 3xy. Okay, so as you can see, the 3xy and the 3xy can cancel. These are the same. So that means we are going to remain with 4x minus 3 plus 5y. So this is what we're going to have at the end after simplification. So these are most typical questions that you can actually have. Let's see the 3.3, simplify the following by first factorize. We are told first you must factorize. Okay, what are we supposed to factor out? Do we have anything common between the numerator here? We've got 36 and 54. What is the highest number that we can actually factor out? So it's a matter of trying the numbers 54 and the 36. So we try which one exactly can we use into these numbers. Let's see, we've got 54 here. Divide by 18. Is it possible? Yes, 18. Then 36. Let's see, 36 here. Divide by 18. That's a 2. So which means 18 is the highest common factor that we can factor out. So that means we can factor out 18 A, B, C. 18 A, B, C. Okay, so if I factor out 18 A, B, C, that means I have to divide now. Remember, 36 divided by 18 gave us 2. So we're going to obtain 2 here. A, B, C, and A, B, C will cancel. So that means that it's 54 in 18, we got 3. So it's going to be 3. Here we've got A squared divided by A, that is A, B squared, B cubed, that's a B cubed, divided by B, which is going to be B squared. C divided by C cancels. So that is what you're going to have. Everything over 162 ABC. So that means the ABC can cancel, ABC, this part can cancel. We are left with 18 and 162. Can these two be divided? This one you can just divide on your calculator. 18 divided by 162, we got 1 over 9. So that means we are going to obtain at the end, we have said it's 1 over 9. So it was supposed to be 1 over 9 like this into 2 minus 3ab squared. So you can write your answer like this, or you can even write it as 2 minus 3ab squared over 9. Still one and the same thing. So that was our 3.3. As you can see, guys, it was just a matter of your factorization. Then we can simplify further. Okay, let's move on to 3.4. Determine the following. Okay. Determine the following from the algebraic terms. Already we are given the algebraic terms, the prime factors of each term. So we're asked to find the prime factors of each term. These are the terms, 168. So 168, and we've got this. So here, guys, we have to at least work it down aside. Right, let's start with 168. We've got 3.41. So we're going to start with 168. Not once, it's just 68, this one, not 168, but 68. So we've got 68 x y squared z to the exponent of 6. So what you're focusing is the 168 here as a product of its prime factors. That means we have to divide the smallest number that we can use into this 68, and that, what is the smallest number that we can have? That is a 2. So you can even try 2 here. 2 into 68. If you divide 68 divided by 2, that is 34. 34, we divide again by 2, that is 17. Then we do not have anything, so we just have 17. So that means this 68 that we see can be written as 2 to the exponent, because we've got 2 times 2. So 2 times 2 is same as 2 to the exponent of 2 times 3 times, we multiply the x, this part we just have to multiply as it is this one. All right, so that was it for 68. But since we are told now for we are supposed to use everything, we are supposed to do this for the 2. So we're going to move on to the other one, which is the 16 x to the exponent of 4. So we've got 16x to the exponent of 4. Y to the exponent of 5, z to the exponent of 3. So let's try 16. But for 16, it is going to give us 2 times 2 times 2, 4 times. So it's 2 to the exponent of 4 times x to the exponent of 4 times y to the exponent of 5 times z to the exponent of 3. So that was the 3.41. We have written this as prime factors. Okay, then 3.42, the lowest common multiple, which is the LCM. Then what is the LCM? Remember, guys, I told you about LCM, that the LCM, we are supposed to take the one that has got the highest exponent here. It has to appear, and we are supposed to take the one with the highest exponent. So if, in terms of 2, the one with the exponent, highest exponent is 2 to the exponent of 4. So our LCM is going to be 2 to the exponent of 4. Then we move on to 3. 3 is appearing here, so you have to take this 3, multiply by 3, multiply by, we move on to x. The one with the highest exponent is this one, x to the exponent of 4, x to the exponent of 4. So we're going to multiply by x to the exponent of 4 times y. We've got y to the exponent of 5. Z, we've got z to the exponent of 6. So that is what you're going to have. So here we just have to multiply 2 to the exponent of 4 times 3, which is 16 times 3. 2 to the exponent of 4 is 16, then 16 times 3, which is 48. All right, so we are going to have, I left something here. We got 17, if I'm not mistaken. There was a 17 here. Here there was a 17. So we are supposed to multiply also by a 17 there. Remember a 17 that we had. I don't know how did I forget to write it. Okay, anyways, let's multiply by 17 here. It's going to be 816. I just hope it didn't affect anything. All right, x to the exponent of 4, y to the exponent of 5, z to the exponent of 6. So that was our LCM. All right, 3.43. All right, let's see 3.43, what we're being asked to do here. The highest common factor now. Remembering that the highest common factor has to be common throughout. It has to be common throughout. So that means which part now that is common? If common, then we take the one with the smallest exponent. So let's start with 2. 2 is common, as we can see, but which one has got the smallest exponent? We've got 2 squared. So it's the one that we are going to have, which is the 2 squared. So here we need the highest common factor, which is the HCF. So we've got 2 squared. We move on to x. Is x common? Yes, x is common. The one with the smallest exponent here, it's x. So we are going to multiply by x. We move on to y. We take the one with the smallest exponent, which is y squared. Yeah, we've got y squared. So we're going to multiply by y squared times. We move on to z. The one with the smallest exponent, that's z to the exponent of 3. So we're going to multiply by z to the exponent of 3. All right, so 2 squared, that is 4. So it's going to be 4x y squared z cubed. So this was the HCF of the given information. So I just hope all this was fine with us on answering, guys. The question 4, the first part was for us to solve the equation. Solve, that's a linear equation. So you just have to expand brackets, collect like terms. That's it. That's it. All right. So 3 by 5 here, that's 15x. Okay. 3 by minus 2 here, which is negative 6, which is equal to 2 by 4, that is 8x. 2 by 11, which is 22. So this is going to be 22. Collect like terms. So that means we are going to transpose the 8x to the left-hand side and it becomes a negative. So we've got 15x minus 8x, which is equal to, already here we've got 22. Then we can transpose the minus 6 to this side, which is going to be a plus 6, like that. Okay, so 15 minus 8, that we can even use your calculator, guys. 15 minus 8, that's 7. So it is going to be 7x is equal to 22 plus 6, which is 28. Divide by 7 both sides. So x was going to give us a 4. So that's what we're going to have in this part. After we've got 4.2, manipulate the given formula and make S the subject of the formula. All right, so what can we do, guys? We're supposed to manipulate, to change the formula into the one that we are supposed to. So we are asked to manipulate. So let's just see what we can do here. Let's just write it aside. All right, so we're given the equation. That's 4.2 u squared plus 2as, which is equal to v squared. So that was the equation that we are supposed to actually work from. All right. So here we can simply transpose, as we can see, the u squared has nothing to do with s. We can simply transpose it to the right-hand side. That means we are going to have 2as, which is equal to v squared minus u squared. Okay, noting that what we are supposed to do is to make s to be the subject. So here we are multiplying, so we just have to divide by 2a both sides. The moment we do this, this can actually cancel out. That means we are left with s. So therefore, our s is going to be v squared minus u squared over 2a. So by this, we have made s to be the subject of the formula. So let's move on to 4.3. use the answer in 4.2, the one that you got in 4.2, and substitute the following values to calculate the displacement, which is S, when U is 0 meters per second, V 5 meters per second, and A is 3 meters per square second. So it's a matter of substitution, as we are taught already here. We have made S to be the subject. So this is 4.3. They are just saying substitute now the values that you are given. We are given V, or V is 5, but this is 5 squared minus U squared. Our U is 0, so this is 0 squared over 2A, which is 2 times our A, which is the acceleration, which is 3. So that is what we're being told just to do. Then you can simplify from there. So this, you can even use your calculator at once, or I don't know what was best for you, but you can just use your calculator here. That's 5 squared minus 0 squared. 0 squared is just a 0, guys, so there's no need for us to do this. 2 times 3, that's a 6, but anyways, that's what you're going to have. So it's going to be 25 over 6, or as a decimal, that's 4.1667, something like that, which is 4.167 meters. Remember, this is distance, displacement measured in meters. Okay, so that is what we're given in this case. Okay, 4.4, we are given two cities that we are given, Cairo and we are given Cape Town. A train travels from Cape Town to Cairo at 30 kilometers per hour, which means we are given the speed of the train. The train travels 349 hours, 38 minutes without stopping to reach its final destination. Here we are given the time. Now we are asked to calculate the distance traveled in meters. Okay, so what is the distance that was traveled in meters? So the first thing is for us to calculate at least this distance in kilometers, since we are given the speed in kilometers per hour. So which means our distance was in kilometers. So we're going to calculate in kilometers, then we convert it to hours. Then our time here, we've got 349 hours, 38 minutes, which means you're supposed to convert that 38 minutes to hours. So how do you convert hours to minutes? Okay, the first thing, that is the conversion. Before we talk about the distance, okay, so remember our time. So our time is going to be 349 hours. Then we convert this 38 minutes to hours. We simply have to divide by 60. So it's 38 over 60. So which means that was the time, 349 and 38 over 60, of which if you can simplify this on your calculator, that's 3, let me try to put this side, that's 349. Okay, let me use this one. All right, 349 and 38 over 60. Let's see what you're going to have as a one fraction, which is this 1,489. That's 10,489. 10,489, everything over 60. So as we saw, guys, that everything is over 30, not 60, but 30. This is over 30. All right, so this is our time now in hours. We have our time in hours now, and the speed in kilometers per hour. So that means we can calculate distance, knowing that distance is equivalent to the speed by the time that is being traveled. That is distance, which is speed times time. So the speed is already in kilometers per hour, which is 30 kilometers per hour, times the time, which is 10,489 that is over 30, which is in hours. So simplifying this on your calculator, this was going to cancel. Then you are going to remain with 10,489 kilometers. Take note, guys, your speed was kilometers per hour, your time was in hours, so this is going to be in kilometers. Then now you can convert to the units that you are given, because you're asked to calculate this distance, but it is supposed to be in meters. So in meters, we know that in a kilometer, we've got 1,000 meters. So what I'm going to simply do is to multiply by 1,000. 1 kilometer is equal to 1,000 meters. So this to be in meters, just multiply by 1,000, and that will be something, just adding zeros here. So it's going to be something like this. That's 10, 4, 8, 9. Then we put these zeros like that. Now it is in meters. So that was the distance which was traveled from Cape Town to Cairo in meters. So I think that's clear. That's clear, guys. As we can see, it was 4.4. Okay, so that was our 4.4. Let's see the other part of the question. 4.5, we are given that a belt is driven by a pulley at, that is the speed, and we are given the rotational speed, which is in revs per minute. Calculate the rotational frequency in revs per second. All right, so what are we asked to do is to calculate the rotational frequency. So here, we just have to apply our formulas. Now, let me cross-check on your formula sheet if we have got a formula which is directly on that so that we can use it, or we are not given that at all. So we have to cross-check. That's our formula sheet here, guys. All right, so let's check the other page and see if we are given. So as we can see here, we are not even given that. So what are we going to do? Let us apply the formula that was supposed to be used. Okay, I'm going to show you. All right, so in this case here, we are given this answer is supposed to be in revs per second. This is revs per minute. So what do? We simply have to divide by 60 minutes. So which means our N is going to be 560 divided per minute, which means we have to divide by 60. It's going to be revs per second. All right, so that's 560 over 60. What do we have? 560 divided by 60 here, which is 28 over 3. So we are going to obtain 28 over 3 revs per second. This driven belt, which is the speed, this is just the rotational. So there's nothing that has to do with meters per second because our answer is supposed to be revs per second. So this is fine. All right, question 5. Okay, sorry for that. Question 5, we are now given a certain equation, which is the equation of a straight line. If we are to cross-check the format, that's an equation of a straight line. So from this equation of a straight line, write the equation in the standard form of y is equal to mx plus c. Okay, so what do we need? We just have to expand everything, clear the fractions. Okay, I'm just going to write it. Sorry for that, guys. I forgot to do this. Okay, so I'm just going to write this down. Equation, which is 5.11. So we've got x over 2 plus y over 3, which is equal to 1. So the LCM or the LCD of the fraction, we've got 2 and 3, which is 6. So we have to multiply this by 6, multiply this by 6, multiply this by 6. So what do we obtain by doing this? We can cancel here the 2 and the 6, that's 3x. The 3 and the 2, 6, that is 2y, which is equal to 6. So I can transpose. Remember, the format is y is equal to mx plus c. So that means 2y is equal to, we can transpose 3x to the other side of the equation, which is going to be minus 3x plus 6. So dividing by 2 both sides gives us the format of the equation, which is y is equal to minus 3 over 2x plus 6 divided by 2, which is 3. So that is the format that we are being given, that we are asked to do or to write in. Okay, 5.12, determine the gradient. Once we have got this format, we know that the gradient is simply taken from the m here represents the gradient. So 5.12, our gradient was going to be negative 3 over 2. So that is the gradient, negative 3 over 2. Okay, then from there, 5.13, determine the y-intercept in coordinate form. The y-intercept in coordinate form. So what we know about the y-intercept is that x is equal to 0. When x is equal to 0, our value of y is going to be 3 here. So in coordinate form, that is what they're asking you to do. Take note, answer the question. So x will be 0 and y is going to be 3. So that is the y-intercept in coordinate form. Then the other thing is to draw the graph using the graph paper. Now, so we are supposed to draw, and on the same set of x's, draw the graph, which is the hyperbola of y is equal to 6 over x. So that's what we are going to do in this case. We are supposed to have our graph drawn. Okay, so let's see if we have got a space for that. So for you to draw, it depends with the scale that you're going to use on the graph paper, but what is important, this is just a straight line. And remember that we have got the gradient, the y-intercept. So there are two options that we can actually have from the format, because so far we've got the y-intercept, which is 0.3. We can calculate the y-intercept, the x-intercept, sorry, so that we can sketch our graph. That can be fine. So let's just do our calculations here. X-intercept, so that we can have our graph. Okay, so to have the x-intercept, we know that y is supposed to be equal to 0. So this is supposed to be equal to 0. Or you can even take it from here. If y is equal to 0, we've got x over 2, which is equal to 1, because y is equal to 0. So we are going to have x over 2, which is equal to 1. So by cross multiplying, x is equal to 2. So which means we've got 2, 0. Okay, so these 2 points are enough for us to have a straight line. The y-intercept, which is the 0.3, and the x-intercept, which is the 2, 0. These 2 points are enough for you to have a graph. So let's start with the 0.3. 0.3 may be somewhere here. Okay, so I'm just going to mark 0.3. This is 1, 2, 3, 4, 5, and so forth. So this is where we've got our 3 here. So that's 0.3. And 2, 0, that is where we're going to have our 2, 0 here at this point. So these 2 points are enough for you to have actually a straight line. So all you need is to draw the line by joining these points. Okay, so I'm just going to join the 2 points so that I can have my straight line. Okay, that's the 2 here. Let me try to reduce it back a little bit. This ruler, I think, is too big for us to draw. All right, so I'm just going to reduce this a little bit. Okay, now like this, all right. Let me also rotate this way. Somewhere there. All right, somewhere here. Yeah, something like this. Okay, so you can join these 2 points. By just joining those 2 points, you have your graph. That is what you're supposed to have. So meaning I can write the equation the way that it was x over whatever that you're given there. Let's check the equation. That was the original equation as it is here, which is x over 2 plus y over 3, which is equal to 1. Okay, so that's x over 2 plus y over 3, which is equal to 1. I have got the graph. That's the straight line that I was asked to do. Okay, so cross-checking the other part of the equation. On the same set, take note here, on the same set of x's, which means on the same graph, draw, in question 5.14, where we drew this one, draw the graph of, which is the hyperbola of y is equal to 6 over x. So that's a hyperbola, guys, 6 over x. So you can even take it, make sure that you've got your table values. So here we can just create our own table values. Here we've got y, which is equal to 6 over x. Y is equal to 6 over x. So let's just have our table of values for the values of x that we are going to use. So we've got x, y here. So you can start from x, from 0 cannot work. So we're going to start from 1, we move on to 2, 3, I think, and 6. These points, they're enough. Okay, when x is 1 here, with x is 1, if we substitute here the value of x to be 1, 6 over 1, that's 6. If x is 2, if we substitute 2, that's 6 divided by 2, which is 3. 6 divided by 3, which is 2. 6 divided by 6, which is 1. So these points, they're actually enough from 1 to 6. Okay, so let's mark the point 1 versus 6. So the first point here is 1 versus 6. That's 1 versus 6. So I'm going to mark the other points here. This is 1, 2, 3, 4, 5, 6, and so forth. Okay, so we have got 1 versus 6. That's a point 1 here in x and 6 in the point mark there. 2 versus 3, that's 2 here versus 3, which is somewhere this point. Okay, somewhere here, that's 2, 3. 3, 2, when x is 3, y is 2, which is somewhere here. And the last one was 6 versus 1. So this is 6 versus 1, which is somewhere here. That's 6 versus 1. Okay, so from this part, you can actually join these points to have your graph. Okay, so these points, they are enough to us to join from this point to this point here, to this point here, to this point there. So that was your graph of y is equal to 6 over x. So the question was for you just to have the graph. So we've got on the same axis, just like the instruction. Okay, so this part was done, is done. Let's see the other part of the question, which is now question 6. We are given triangle ABC and also triangle ADE. These are the two triangles that we have as similar. This triangle ABC is actually similar to ADA, and we are given all the other values and other angles. Okay, explain the meaning of the symbol here. Okay, so they want you to explain this meaning here, guys. This symbol. So this is just similar, guys. Okay, so that's similar. Okay. 6.2, we are now asked to name two conditions for triangle to be similar. What are the conditions? Okay, the conditions can be from angles, okay? That is equal angles. You can have equal angles throughout. If we have got equal angles throughout, then these triangles can be actually be similar, or they can be equal shapes. Those ones, they can be actually equal in shapes. That can make them also to be similar like that. So there are so many reasons that we can have, but those are the most that we can actually use. 6.3, calculate the length of the side DE by using Pythagoras theorem. DE, this is our DE. We are now asked to use Pythagoras theorem, guys. As you can see, this angle is 90 degrees. So that means we can apply, because this is our H, which is the hypotenuse. So knowing that hypotenuse squared is equal to side squared plus side squared. So our hypotenuse is the DE, so that means DE squared is going to be any of these sides. So it's going to be 8 squared plus 6 squared. Okay, so you've got a DE squared is equal to 8 squared, that is 64 plus 36. So we've got DE squared, which is equal to, if we add, we've got 100. So to find DE, we have to introduce the square root both sides. So therefore, our DE is going to be 10 from the square root of 100, which is 10, and that is 10 meters. So we've got our DE as 10 meters from the Pythagoras theorem. Okay, so that was the application of the Pythagoras theorem to calculate DE. 6.4, we are now on 6.4. We are now asked to calculate the length of BC by using the properties of similar triangles. So take note that one, we said it's similar. So we want to calculate BC from similar triangles. What are the which triangles are similar? These are the two triangles which are similar here, and we want to calculate BC, and this is 6.4. Okay, so I'm just going to erase this part a little bit so that at least we can work from this side here. All right, 6.4, let's write it here. So we know that from similar figures, we've got triangle ABC, which is similar to triangle ADE. So this is ADE. So we know that the ratio of sides is the same. We've got AB over the corresponding side, which is AD, is equal to BC. So it's BC over the corresponding side, which is DE, which is equal to from A to C. So this is AC over the corresponding side, which is AE. So that's how you take the similar, the ratio of sides from similar figures. And from there, you are supposed to calculate, take note what you're supposed to calculate. Let's get back to the question. The question is for us to calculate BC. So we are going to insert or to substitute the other values so that you can have your BC. So here we are going to compare what we have and what we are supposed to calculate. We want to calculate BC, so this ratio is to be taken. BC over the corresponding side, which is DE. Do we have DE from D to E? We just calculated the D to E. That is 10, which is equal to, from these two, we are supposed to take any one bar as long it has got everything inside the ratio. So I want us to cross-check from A to B. We have got it A to B. That's A here to B. That is 8 plus 10, which is 18. So it's going to be AB, which is 18, over AD from A to D, that is 8. So you're going to have something like that. So you can calculate BC by multiplying by 10 both sides, by multiplying by 10 both sides. This makes these two to cancel. Then we can remain with BC. So that means our BC was going to be 18 over 8 times 10. And that we can actually use our calculator. 18 over 8, whatever that we have here, we multiply by 10, which is going to be 45 over 2, or 22,25. So this was going to be 22,25 meters. Take note of the units that you're given. Maintain the units that you are given. The others is meters, so it has to remain also in meters. Okay, so that was 6.4. 6.5, calculate the magnitude of the angle C. So this is angle C here. That is our angle C. So guys, we know that angles in a triangle, they simply add up to 180. You have got 90 and 63. But we know that angles in a triangle, they add up to 180. So I'm just going to subtract from 180. So angle C is going to be 180 degrees minus the two angles that we have inside this triangle, which is 90. This symbolizes 90 degrees. This right angle here, that's 90 degrees. Already you are given here. Angle A is 90 and that one is 63. So we are going to add 90 and 63 together. 90 degrees plus 63. So we are going to have 180 degrees minus 90 plus 63. What do we have from 90 plus 63? That's 153. So that is 153 degrees. And if we subtract this 180 minus 153 degrees, we are going to obtain 27. So this is going to be 27 degrees, which is angle C. So our angle C here was going to be 27 degrees. So this one, we just use the idea or the application that we know about the angles in a triangle. So guys, some of these questions, we can actually use that advantage from what we know of the properties of a shape. Okay, so let's see the other part of the question, which is question 7. Draw the graph of y is equal to sine x from 0 to 180 on a graph paper. Okay, so actually we're supposed to have a table of values that you're going to follow for you to have this graph. That was the best thing that you can have, but without wasting here, I'm just going to have a sketch. I'm not going to use the graph. I'm going to do this like as a sketch. Why here? Because I think this one was actually clear, so I'm not going to. But if you are to use a graph paper, then it's fine. We have got our graph paper here, but now I have a lot of things that I've written here. So I'm just going to show you what you are supposed to do on a sketch. Take note of the range that you're given from 0 to 180. So this is 7.1. We've got the graph of y is equal to sine x, which is supposed to be drawn from 0 to 180. Okay, so as we actually know that from this graph, we are going to have just a table of values that we are going to use. All right, table of values. Okay, so let's see. Going to have this x and y here. I've got a 0, 90 degrees, 0 degrees, 90, and 180 degrees. Okay, so when x is equal to 0, you can substitute. Sine 90 gives you 0. Sine 180, that's 1. Sine 180, that's 0. Sine 90 is 1. So you can use your calculator, guys. Sine from your calculator like this. Sine 90, you get your answer, which is 1. Sine 180, you get your answer, which is, that's what I'm trying to say. So you have your values. Now you can even draw, but like I said, I'm going to sketch. I'm not going to draw that one on the graph. I'm just going to show you what it was supposed to be like. Okay, so this is what we have from 0 to 180. That's 0, 90 degrees, 180 degrees. Okay, then here we've got 1 and minus 1. Okay, so the first part is at 0. You mark 0 degrees versus 0 at y. So that's here. 90 versus 1. So 90 versus 1, you mark a point. 180 versus 0, that's 180 versus 0 here. You mark a point. So make sure that you mark the points first. Okay. After marking the points that you are given, then you simply have to join those points. So the graph was going to be like this. It was not going to be a full one like the one that we are used to, like this one. No, it was not going to be like this. Okay, so this is the graph of y is equal to sine x as it is drawn from 0 degrees to 180 degrees. So that was it. 7.2, we are given a certain layout of a building that we have here. A doorstep wedge is shaped as a triangular prism. That's a triangular prism. The wedge's angle of elevation must be 20 degrees in order for the wedge to be effective as what we are given here. Calculate the vertical height of the wedge if the horizontal is 12 centimeters with aid of trigonometrical. Guys, this is just direct. According to this angle that we are given, this is the vertical, which is according to 20 degrees. This is the opposite side, and that's the adjacent side. And we know that from our trigonometrical ratios, SOHCAHTOA, which we most use, guys, this one, SOHCAHTOA here, we know that for us to apply adjacent, opposite and adjacent, it must be on tan, opposite and adjacent. And we know that tan is opposite over adjacent. So I'm just going to write it somewhere here. All right, so tan theta is supposed to be opposite over adjacent, which is tan of the angle, which is 20 degrees, is equal to the opposite, which is the AC, over the adjacent, and our adjacent is 12. So that's it. We can calculate AC by cross multiplying, because this is the same as over 1, so you can even cross multiply here. So that means 1 times AC is AC, 12 times tan 20, that's 12 tan 20 degrees. Okay, so 12 tan 20, that's from our calculator. 12 tan 20, like that, tan 20 degrees, like this. We are going to obtain 4.3676, something like that, which is 4.36, what, let's check, 367, which is going to be 8. Remember, 6 is going to change this 7 into 8, so it's 6, 8. All right, then the dimensions, they are in centimeters, so which means our AC is going to be in centimeters, just as usual. So take note, guys, we are being asked to calculate the vertical height, the vertical. That is why I am calculating AC. That is the vertical height that we are given. So take note of what you are being asked to calculate. I think by that it can actually help us. So that was it, guys, for this question 7.2. In fact, everything about question 7, we have got 7 marks for that. Okay, so let's move on to the part of the question, which is question 8. Question 8, question 8, question 8. There's a lot of things there. A melder wants to sell funky doorstep wedges shaped as a right prism, just like what we had before, but it's not that one, it's another question. Okay, so don't take the information from another question to another question. Don't do that. Okay, so here we are given the dimensions, the 10, the 8, the 2 meters, and we've got right angle here. Okay, so the first question is to calculate the volume of wood needed to manufacture one door wedge in cubic meters. Okay, so we need to have the volume. So for you to have the volume, it's actually what you see, because here we can see that this shape here, I want you to see this triangle that we see here, BDF, this triangle, is the same as the triangle which is going to appear on the other side here, which you see there. So area times the height, that is the length from one side to the other, is going to give you actually the volume. That's how you actually work out volume. Okay, so what I'm trying to say, okay, sorry for that. What I'm trying to say is this, guys. Let me show you. We are supposed to calculate the area of this shape, this one triangle that we see, which is triangle DBF. So that is the area times the height. So volume is simply this. Let me write it here. Volume can be obtained by this 8.1. That is the base area times the height from one side to another. Okay, so the base area, now we need to calculate the area of the triangle, but as we know that the area of a right angle triangle is actually half base times the perpendicular height. So here we've got the base from 8 here, 8 centimeters, that is the base. and we do not have the perpendicular height here. This is the height. So which means we are supposed to calculate this using Pythagoras theorem. Okay, we used the Pythagoras theorem last time, so we are going to apply that. This is going to give you 6 centimeters if you apply your Pythagoras theorem properly. So therefore, the volume now, it is going to be base area, which is half base, times perpendicular height, which is half, times the base, which is 8, times the height, which is the one that we calculated, which is 6. Whatever that we get here, we multiply by not the height of the triangle, but this one is the length from one shape to another, from this triangle to this triangle. We have got 2 centimeters here, which is the same as here, which is 2 centimeters. So whatever that you get, you multiply by 2. So that was going to be the volume. So let's first calculate the area of the triangle, which is half of 8 by 6. Half of 8 is 4, actually, isn't it, guys? This is 4 times 6, which is 24. That is what you're going to have, okay, which is 12, 24. So we're going to have 24 by 2, which is left here, which is going to give us 48 cubic centimeters. That's the volume. So on volume, guys, you're supposed to take note of the information, how you answer your questions. Please take note. So that was 8.1 to calculate the volume of the shape. And let's see the other part. 8.2, we are now given that the floor of a room is 7 meters by 3 meters. The floor is covered with the ceramic tiles of 300 millimeters by 300 millimeters. Determine the surface area of the room. So we are asked to calculate the surface area of the room, which is measuring 7 by 3. So you just have to multiply here. That is the area of the room, which is 7 by 3. That is 21 square meters. That is, remember, area, guys, it's just a room, a floor. It's a rectangular shape. Okay, then 8.2 to determine the surface area of one tile in meter square. Okay. There we are being told to answer in meters square. These are millimeters, so we're supposed to convert them to meters. Okay, so that's the thing. Area we're supposed to just multiply, but we are told now the units to use in square meters. So let's convert millimeters. We know that in a meter we have got 10,000. As a 10,000 or 1,000, that is 1,000 millimeters, because in a meter we've got 100 centimeters. In a centimeter we've got 10 meters, 10 millimeters, sorry. So 10 by 10, that is 10 by 100, that is 1,000. So if 1 meter is 1,000 millimeters, what about 300 millimeters? I'm just going to divide by 1,000. So here we need 300 millimeters. In meters, you divide by 1,000. So it's 300 divided by 1,000, which was going to give us 0.3 meters. So this simply means we've got 0.3 meters, 0.3 meters. Okay, so now for us to have the area, we are just going to multiply just like what we did here. So it is going to be 0.3 times 0.3. We have got our area in meters. So 0.3 by 0.3, that's what we need. 0.3 by 0.3, which was going to give us 0.09 square meters. So this is 0.09 square meters. Okay, now on 8.23, how many tiles will be needed to tile the room if no tile are broken round up? Okay, we are told to round up. Okay, so this is the area of a tile. This is the area of the floor. Take note. So how many tiles do we need? We just need to divide the area of the floor divided by the area of the tile. So that was it. Here, the area of the floor, which is 21, over the area of each tile, which is 0.09. So we can actually round off the answer. 21 divided by the answer that we got before, that is going to be 233, something like that, which is 233. Okay, so we need 233, but nothing is supposed to be broken up. So this is going to be 233,333, and that is what we have. So if no tile are broken, which means the comma that we have there is supposed to give us an extra tile, because that one is there is going to be a space that is going to be left out, and that space is going to be 234 now. Okay, now if 2% on 8.24, we are now given, if 2% of the tiles is broken while tiling, how many extra tiles are needed? If 2% of the tiles, remember, how many tiles do we need here? We need 234. And 2% of it was broken. So if 2% is broken, we just have to calculate that 2% of this, which is 2 over 100 multiplied by 234. Okay, so what is 2% of 234? That is 2 over 100 by 234, just like that, which is 4,6 or something like that, which is going to be 4. So our answer there was going to be a 4. Okay, that was it. I think from that, guys, it's actually clear. As we can see, convert to cubic meters, whatever that we have here in cube. Okay, previously I told you that in a meter, we've got 1,000 millimeters. But here we are told about cubic millimeters. So what do I have to do? I just have to raise this to the exponent of 3, this to the exponent of 3. That means I'm going to remain with 1 cubic meter, which is 1,000 to the exponent of 3, which is from your calculator. It is going to give you, we've got 3s, something like this. Okay, in cubic millimeters. All right, so now we are asked to convert this whole number that we have, which is 250,000 cubic meters, into cubic meters. So we simply have to divide. Okay, so let's divide and see what you're going to have at the end. So we've got 250,000 over, that's 100,000,000. Okay, so let's cancel out the zeros here. We can cancel the 2 zeros. The 2 zeros, we are left with 25 over, this is, okay, 25 over, how many zeros? 1, 2, 3, 4. So it's 100,004 zeros. Okay, so here we can just use our calculator to finish up this. So it's 25 divided by 1. How many zeros? These are 4 zeros like this. That is 10,000, and it's going to be 2,5 times 10 to the exponent of, okay, which is, okay, let's just write it in a way that we understand, which is 0,00025. Is that so? 1, 2, 3, 4. All right, so that is what we are going to have in cubic meters. Take note, the question was for us to write this in cubic meters, and that is what you're going to have in cubic meters. So that was it, guys, for you to have a total mark of 100 in this question paper. So as we can see, it's something that we can actually collect all these marks if possible. It only needs us to have attention on whatever that you're doing, answer the questions properly, follow the instructions that you are given. Each and every part has got its instructions that you'll be given. Follow the instructions, and by doing that, you can actually attempt a lot of questions, and you can actually even totalize this question paper. So that's it, guys, from Meson African Motives, working on engineering. And that's it for Mathematics N1, which was written November 2022. Till we meet again.